Okay, in this video we are going to cover the partial fractions of the imaginary roots. So here the heavy side is going to work, but you have to be careful because you are going to use imaginary numbers. Okay, so first of all, what are the roots? Well, this is the power of the denominator is 4, so that means that you should have 4 roots and then you should have 4 partial fractions. Okay, so for the first one is s1 and 2 is equal to plus minus I. That is the first 2 roots of this one. And the roots of this is s3 and 4 equal to 2 plus minus 2i. Why those are the roots? Well, you can calculate it like this. S squared plus 4 equal to 0. You are looking for the value so that this becomes 0. So that is why I make it equal to 0. So s squared, the 4 to the other side, minus 4, and then you apply the square root. So s is equal to the square root of minus 4. And when you apply a square root, you always have to use plus and minus. And because this is square root of minus, then it's going to be plus and minus. Square root of 4 is equal to 2, but the square root of minus is going to be equal to I. So that is why you have the 2i. In case you don't know why those are the roots. But anyway, let's focus on the calculations of the constants. Okay, so the partial fractions of this is going to be as plus b over s squared plus 1 plus cs plus d over s squared plus 4. Now you have your 4 partial fractions and you have your constants a, b, c, and d for a 4-degree denominator. Okay, now how to calculate the values of a, b, c, and d? Okay, let's use the Heaviside method. Okay, in the Heaviside method, if you are going to calculate for this one, okay, if you are going to calculate for that one, all you have to do is use this fraction, but without the s squared plus 1. So as plus b is equal to 3s plus 2 divided by s squared plus 4. So you cancel the s squared plus 1. And now you have as plus b. Now, the next step is to replace the value of the root for this one, which is plus and minus I. You can only choose one plus I, which is irrelevant because when you make the replacement, it's going to be a square, is going to make it positive. But you can choose just plus I and let's replace it. So in the A is going to be A times the S, the imaginary number I plus B equal to 3I plus 2 divided by I squared plus 4. Okay, so here what you have is B plus AI. I usually write first the real part and then the imaginary part because this is going to become a complex number, and then equal to 2 plus 3i, and the denominator I squared happens to be minus 1. Minus 1 plus 4 is going to be 3. So in the end what you have is b plus I equal to 2 over 3 plus the I. Okay, so for a complex number to be equal to another complex number, the real part must be equal to the real part and the imaginary part must be equal to the imaginary part. So here b is equal to 2 over 3 and the value of a is equal to just 1. The coefficient here is 1. Okay, so here you calculated the values of a and b. You calculate this and this. Okay, now let's do the same but for the other. Let's do the same for the other. Okay, so for the other is you are going to calculate this partial fraction c and d. So you, from this fraction, you cancel the s squared plus 4. So what you get is as plus, cs plus d, this fraction, and it's going to be equal to 3s plus 2 divided by s squared plus 1. And then you replace the value of the s equal to 2i. Okay, so let's make the replacement. C times 2i plus d equal to 3 times 2i plus 2 divided by 2i squared plus 1. Okay, let's see what happens. I'm going to write again first the real part and then the imaginary part. D plus 2ci equal to 2 plus 6i divided by, now 2 squared becomes 4 and the I squared becomes negative, so it's going to be minus 4 plus 1. So d plus 2ci is equal to minus 4 plus 1 is going to be minus 3, so it's going to be minus 2 over 3 and then minus 6 over 3 2i. Okay, so the value of d happens to be minus 2 over 3 and the value of c is equal to d is equal to this and d is equal to this. So c is equal to minus 1. Okay, so what we have done is to find the values of the a, b, c and d. So the value of a is s plus the value of b, 2 over 3 over s squared plus 1 plus the other fraction, this fraction. C is equal to minus s plus the value of d minus 2 over 3 over s squared plus 4. Okay, now if you are asking, if the problem is asking for the Laplace inverse, so from here you can split these fractions in the Laplace inverse of s over s squared plus 1, okay, plus the 2 over 3, I'm going to take it outside, 2 over 3, the Laplace inverse of 1 over s squared plus 1, and then plus, actually minus the Laplace inverse of s over s squared plus 4, okay, and then minus 2 over 3, the Laplace inverse of 1 over s squared plus 4. Sorry for the space. Okay, now from here we are going to use the formulas of the sine and the cosine Laplace transform. So here, this one happens to be just the cosine of t. Here, 1 squared, so that is the value of k. So this is the cosine of t. This 2 over 3, this is going to be the sine of t, if you check your formulas. Here is 1 squared, and this is 1. Okay, minus here is the cosine of what? Well, this 4 happens to be 2 squared, so that is 2t for the formula. And finally, minus 2 over 3, be careful here, is the Laplace inverse of 1 over s squared plus 4. It is actually the sine, but you have to complete the formula. Because this is 4, you have 2 squared, and the formula says that the Laplace inverse of the Laplace inverse of k over s squared plus k squared is equal to the sine of kt. Okay, so here you cannot apply this formula because you need the 2 here. So what you are going to do is complete the formula 2 and then compensate that with 1 over 2. And then you can apply the formula. So the result of this is these 2 and these 2 cancels. From here, minus 1 over 3, the sine of 2t. Sorry, 2t. And this is the result of making the Laplace inverse of this. So engineers, this is the method to find the values of a, b, c and d for imaginary roots. So again, you can still use the Heaviside method. It's a very easy method, but you have to be very careful because you are going to handle complex numbers, alright? So be careful with the I and the I squared, alright? This is the example, and tomorrow we are going to see some other examples and more formulas. For today, that is enough.